Hi guys, let's solve this exact differential equation. Of course, we have solution. So the general form of exact differential equation is m dx plus n dy equal to 0, where m is equal to the first function here, 5x² + 3x²y² minus 2x³ and n is equal to 2x³ minus 3x²y² minus 5y⁴. So now we want to check if this equation is exact before we start the solution. So let's do this together. We have partial differentiation of m. Of course, we go with respect to y. We have the x here, we go with respect to y. We can't maintain the same variable, so we have the x here. We must differentiate partial with respect to y, and coming to this case, we must differentiate partial with respect to x. So we can't have the same variable. So differentiating this guy with respect to y. This is 0 because it doesn't contain y. Coming to this one, it contains y, and differentiating y square, keeping x constant. Differentiate y square is 2y. 2y multiply. This question contains y here. Sorry. Okay. So we have y here. All right. So differentiating this guy with respect to y give me 2y multiplied by 3x squared is 6x² y minus differentiating this guy with respect to y, differentiating this y³ should be 3y squared. 3y squared multiplied by 2x will give us 6xy squared. Or we can just, the way we do our normal differentiation, 3 times 2 is 6x, then coming to y, we remove 1, we have 6xy squared. Okay, we have partial differentiation of n with respect to x in this case. With respect to x, the cube belongs to x, so it is 2x³ y. With respect to x, 3 times 2 here is 6. Remove 1 from the power, we have x² y minus differentiating this guy with respect to x is 2 times 3 here is 6. Remove 1 from x, then we have y squared. Then this guy does not contain x. Since the differentiation is with respect to x and y is constant and this guy is 0, then if you watch closely, you find out that this differentiation and this partial differentiation, they are having the same value. Therefore, we can state that partial differentiation of m with respect to y is the same thing as partial differentiation of n with respect to x is exact. Right? Now, the solution. Let's solve the equation now. There exists the main function implicit z of x, y such that partial differentiation of z with respect to x is equal to m. Okay? So partial differentiation of z with respect to x equal to m, then integrating both sides, we are going to have integral of this, of course, integral of the x, the z should give us z. So when you integrate, you remove the what? Differential coefficient. So we have the function z of x, y is the integral of m with respect to x plus some constant, because we integrate with respect to x, meaning that y is constant, then the constant should be a function of y. We have c of y. Okay? So that we have our z to be equal to integral m value is our m is 6. Our m is 6. Sorry, is our m is 5x4 plus 3x²y² minus 2xy³ with respect to x plus c of y. Okay? Then z is equal to integrating this guy with respect to x, we're going to target our integration on only x variable because we are keeping y constant. So integrating 5x raised to the power 4, we have 5x raised to the power 5 over 5, incrementing the value power of x, then integrating the variable x, we have 3x, the 2 there we have 3, we have y squared over 3, minus 2, integrating respect to x, we have x squared y cubed all over bring down 2, then we have plus c of y. Okay, so this will take out these values. We have z to be equal to x power 5 plus x cubed y squared minus x squared y cubed plus c of y. So this is our main function, implicit function that has this particular exact equation. So, but we need to find the value of c of y to have a complete solution. Okay, for us to find the value of c of y, we'll remember also, we recall also that there exists also partial differentiation of z, in this case with respect to y, equal to what? N. Right? Then we're going to differentiate this particular function to be able to find c of y. We're going to differentiate this guy with partial with respect to n and equate it to what? N. With respect to y and equate it to n. So we have the partial differentiation of z, and z is all the function here. So we can have the partial differentiation with respect to y of z, and z is x raised to the power 5 plus x raised to the power 3y squared minus x raised to the power 2y cubed plus c of y. Okay? Plus c of y equal to n. Of course, our n is equal to 2x cubed y minus 3x squared y squared minus 5y 4. Okay? So differentiating these guys with respect to y, this is x raised to the power 5, it doesn't contain y, it's off. Then differentiating this guy now is going to give us 2. We come down there, we have 2x cubed, then remove 1 from the power of y, we have y, or we can just say differentiating y squared is 2y, 2y multiplied by 3x cubed is multiplied by x cubed is 2x cubed y. Then here, remember we are differentiating with respect to y, then x is seen as what? Constant. So differentiating y cubed is 3y squared. 3y squared multiplied by x squared will give us 3x squared y squared. Then differentiating c of y is c prime of y equal to, repeat everything here, 2x cubed y minus 3x squared y squared minus 5y 4. Then watching closely on both sides, find out we have the same thing on both sides. We have here 2x cubed y, we have 2x cubed y, we have 3x squared y squared, we have 3x squared y squared. So this guy can take away this guy from both sides, and this guy can take away this guy from both sides, so that we have c prime of y is now equal to minus 5y raised to the 4. Then to find the value of c of y, we have to integrate both sides. Then integrate both sides, so we have integral of c prime of y is equal to minus 5 integral of y raised to the power 4 dy. So bring out the constants that's in the bracket. So integral of c prime of y is c of y, and integral of y raised to the power 4 is y raised to the power 5 over 5 plus k. So this guy can go with this guy, so we have c of y to be equal to minus y raised to the power 5 plus k. Right? So, but our main function is z equal to this guy, then we have c of y. We've gotten the value of c of y now, so we're going to substitute here. So that therefore our main answer is x raised to the power 5 plus x raised to the power 3y squared minus x square y cubed. And c of y now is minus y5 plus k. Alright, then take k to come to this side. We have z minus k, so that we'll get the constant is x raised to the power 5 plus x raised to the power 3y squared minus x raised to the power 2y cubed minus y raised to the power 5. So that a will be equal to x raised to the power 5 plus x raised to the power 3y squared minus x raised to the power 2y cubed minus y raised to the power 5, where a is equal to z minus k. And we have our final answer. Thank you, and follow, subscribe for more. God bless you.